Good afternoon, everyone. Let's get started. Today, we are going to talk about abstract data types. These are today's topic. First of all, I'm going to talk about course logistics, and then going to introduce what abstract data type is. And I'm going to describe abstract data types with a real-world example. And then I'm going to summarize this lecture. First, course logistics. Homework 2 was due today, and homework 3 will be out on this Thursday. And the test cases for classes got updated. You can click on this link to check the reason for the error. When you click the homework 2, I actually updated the test cases. So let's see. Homework 5, it asks you to implement a class account. And when you try to run this run docstring, it occurs an error. And that error arises from the update of this of the official Python. And the developers are trying to fix this problem. Anyway, if you are interested, you can have a look at this PR. So you can just run the updated test code. And after you write your code, you can test your code with this code block, okay? Actually, this one is not for test, like this one is for assertion. However, we cannot run other test units like unit test or other test libraries. Therefore, I'm just using assertion here. Anyway, that is a little update to our test cases. And from today, we'll have online live lecture. And I guess most of you understood that today is the first day of the online live lecture, and quite a lot of you appeared here. And due to restricted resources, recitation will be pre-recorded from now on. So from this week's recitation, it will be pre-recorded. Because we have just one TA and he already has a lot of job to do, and he cannot run recitation as well either. And before we go on, I would like to receive some feedback from you guys. You can click this link, or I'll leave this link on the chat. I'll give you 2 minutes, and please provide class feedback, like how you feel about this class, the speed or the level, or how it is organized. I'll give you 1 more minute. Okay, thank you for sharing your ideas. Before we move on, do you have any questions regarding course logistics or any suggestions on improving the lectures? Okay. If you have any questions during the class, you can ask right away, or you can just leave a message on the chat. Okay, let's move on. Today's main topic is abstract data type. And what is an abstract data type? An abstract data type, or simply data type, defines the operations and the data supported by an object. Last time we talked about object, and abstract data type defines the behavior of that object we want to define. And abstract data type is a concept similar to mathematical concepts such as functions, set, or sequences. What does it mean? Classes are the Python representation for ADTs. We abbreviate abstract data type as ADT. What about data structures? This course is named Data Structures. And in this class, I'm suddenly started to talk about abstract data types. What are the differences between data structures and abstract data types? A data structure is an implementation of a data type. And a data structure is an object that provides all the operations defined by a data type with the correct behavior. And there can be multiple ways to implement one data type. So from now on, let's differentiate the difference between ADT and data structures. The definition of ADT only mentions what operations are to be performed, but not how these operations will be implemented. And how to implement an ADT corresponds to a data structure. Therefore, as you can see here, ADT just defines the operations and the data types an object supports. And data structures, in fact, implement the operation defined by ADT. Therefore, you can think of it as ADT is a concept, whereas DS is a tangible object. or implementation. An ADT does not specify how data will be organized in memory and what algorithms will be used for implementing the operations. It just specifies the operations or the input and output relations. How we implement the behavior is data structures. It is called abstract because it gives an implementation independent view. It does not care about implementation. Furthermore, it doesn't even care if it is possible to implement that ADT. It just assumes that some data structure will implement that concept. Therefore, some ADT might not be implementable. Therefore, we have the name abstract. And the process of providing only the essentials and hiding the details is known as abstraction. Okay? And why do we care about ADTs? When considering a problem, it is a good idea to think about the data types that will be used to solve the problem. And to define an abstract data type, you need to specify the possible values that the data type can have. So you need to specify the possible values a data type can have. And define the operations that can be performed on the data type. Here, you need to specify two things, operations and data. You can then solve the problem at hand by making use of your new data type. And in the beginning of this course, in the introduction class, I mentioned that sometimes you need to design your own data structures or own data types. And this abstract data type is about that, defining your own data structures or own data types. And you could just ignore its implementation details. And you just say, oh, there might be this kind of ADT, and I can use this data structure to solve my own problem. And this is good for cooperation. One person defines ADT and solves bigger problem, and the other person implements the ADT specified by the other guy. And you can sometimes change the implementation of a data type later, depending on the situation. And when you discover that your original implementation is too slow or has some other disadvantages, then you can change the implementation. However, let's say we have a bigger problem here, and you defined an ADT to solve this problem. However, one day, you just figured out that you have a problem with this data structure you used to solve this problem. If that is the case, you can just change this part, data structure implementation. After this line, you don't have to care about anything. You can use the same ADT to solve the same problem. You just need to change the implementation. This is similar to abstraction barrier between objects and users. Users don't care about how it is implemented. They just use it. Okay, we talked about just abstract concept of ADT. And from now on, we're going to talk about a real world example. Here, we're going to implement a day calculator. And the job of this day calculator are as follows. For a given date, what day of the week is it? You should be able to calculate the day of the week given the date. And for given two dates, how many days lie between? For example, I give 2024 December 12th and 2025 March 9. How many days are between these two dates? Can you calculate this? Our day calculator should be able to calculate this. We're just defining that this day calculator data type should be able to do these operations. And for a given date and a given number of days, what date is that many days before or after the given? And here, we define an abstract data type as date. And this date object should provide support these operations. The first one is, of course, the constructor. You should be able to create a new object, and it receives 3 parameters: year, month, and day. And this date object returns the day, month, and year. And it also returns the day of week as a number. Here we're defining the input and output, and even the output format. And num days receives other dates and returns the number of days between the two dates. And this advanced by method returns date and days further of this current date. And we also want to be able to compare dates using equal or this comparison method, comparison operator. Okay, let's implement this data structure and see how we can use this date object to perform these operations, to solve these problems. Before we go on, are there any questions? Oh, let's move on. So as I told you, this is the specification of the date object. And there might be various ways of implementing this date object. And we're going to implement in this way. And I'll call this implementation as first implementation. Okay, let's first define our date. And it should support the constructor. And I told you that it will receive 3 parameters: year, month, and day. So it will just receive year, month, and day like this. And we're going to make this as semi-private. This is for encapsulation. The constructor was very simple. And what are the other method that we need to support? Day, month, year. Let's implement day, year first. In this case, we just need to return the year. What about month? We just return month. In the case of day, we just return day. This abstract data type doesn't know the implementational details. However, our data structure date implements the ADT. And after finishing this first implementation, we're going to change this implementation. And I'm going to show you that we have several data structures supporting the same ADT. Okay, we have finished the 4 functionalities. And the next one is day of week. How can you solve this problem? Here, we need to use something different to solve this problem. Here, we are going to use a Julian representation. There are conventional date representation. It is done by year, month, day, like 2020, March, and 20 or 19. This is conventional representation. However, when it comes to conventional representation, it's very hard to know whether 2 dates are or the dates between 2 dates. What I mean by this is, when I give you 2 dates like this, can you directly calculate the days between these 2 dates? So this is the first date, and this is the second date. And when I give you these 2 dates, using conventional representation, it's very difficult to calculate the dates between these 2 dates. And to solve this problem, Julian representation uses different date representation. In conventional representation, it uses 3 numbers. 1 for year, 1 for month, and 1 for day. However, in the case of Julian representation, it uses just 1 number. And let's say 2020 March 31 becomes 1 Julian day. Let's say the Julian representation of this one is 1, 2, 3, 4, 5. Then 2020 April 1 becomes 1, 2, 3, 4, 5 plus 1. That is the Julian representation. And so, in the case of Julian representation, the dates are continuous on the discrete space. However, in the case of conventional representation, the dates are not continuous in the discrete space. And we're going to use Julian representation to calculate the day of week. And how do we implement Julian representation? I'll just give you the function. That this one changes the current conventional year, month, day representation to Julian representation. So you don't have to worry about this. And for your information, the first day of the Julian representation is 4714 BC, November 24th. So November 24th, is the first day of Julian representation. Okay, so this is just another way of representing dates. And how do you calculate day of week? If we use Julian date, then day of week becomes very easy. We first need to convert the current date conventional representation into Julian day, like this. And we just return Julian day divided by 7 and the remainder. And this one simply is the day of the week. Okay? Okay, then the next one we need to implement is non-days. In this case, we will just receive another date, and we're going to calculate the dates between these two dates. And this one is very simple if we use Julian date representation. We first convert the other day into Julian day, like this, and we subtract that of the self, the Julian day of the self. If you just subtract these two numbers, then that is the number of days between these two dates. Okay? It's quite simple. And the last one we need to define is advanced by. So this method returns another date that is advanced by this specified days. And to implement this one, we are going to use Julian date as well. We first convert the self as Julian day and just add these days. And after that, we convert this Julian date into year, month, day representation again. Here we are going to use Julian day to year, month, day, like this. And we're going to return a new date object, like this. And I'm going to show you the definition of Julian day to year, month, day. Like this. Different from this 2 Julian day, this one does not contain self. Did you guys notice that? When we convert Julian day into year, month, day representation, we don't have to care about the self's attributes. In this case, we need to access to the year, month, and day to convert the current year, month, day representation into Julian day representation. However, in the case of Julian day representation to year, month, day representation, we don't need self attributes. If that is the case, we do not put self here because we are not using any of the attributes of the self. We just remove this part. And we decorate this function as static method. And this one is called decorator. And what is static method? When we want to use these methods, we need to have an instance. So let's say we define D1 as date. Like this. And D1 dot, then we can call like day method or D1 dot month method like this. However, in case of JDay to YMD, we don't have to create an instance. So we can just call this function like date dot like this and pass any numbers we want. So other methods containing self we need a specific instance. But in the case of static method, we don't have to create an instance. We can just use the class name like this and use this function. Okay. All right. Let's create another date. And test some functionalities like num days, d1 num days, d2. Then it says the num days between these two dates is 11, and the month of date 1 is 3, March. And we can also print day of week like this. Okay. So it works pretty well. Up to this point, any questions? Okay, if you don't have any questions, let's move on. Oh, by the way, if you guys click this class collab, you can access to these code blocks on the fly. Okay, that was our first implementation. And let's think about another implementation. Let's say we are running a social media. And luckily, we have millions of users. And we need to store the date or the birthday of these millions of users. And in that case, is our implementation okay? What I mean by this is we're storing 3 numbers, and that could be quite demanding. And we want to reduce the storage. And how can you solve this problem? That is the second question we want to solve. I already mentioned that this number, in the case of year, month, day representation, we need to store 3 numbers. However, if we just use Julian representation, we can just store 1 number to represent year, month, day. Therefore, rather than doing this, we can just remove this part and store just 1 number, just Julian day. Year, month, and day. And we should not fix this part because this is the interface. Users are going to use our date object following this specification. Therefore, we should not fix these parameters. However, we can change the inside of this method. Okay. And when we make a modification like this, then the storage will be approximately becomes 1/3. So that is just approximation. So we just stored 3 integers, but now we just need to store 1 integer per user. So we are saving a lot of memory space. Okay, I'll give you like some minutes and try to figure out how we should modify other methods to support the functionality following this modification. Okay, think about it on your own. And if you finish implementing this new class date, and send your implementation to me through chatting. Okay, think about it on your own from now on. And if you have any questions, it's okay to ask. Can anyone send your implementation to me? Okay, Songsu got this question. Python allows integer object to have infinite memory space. Is it so? Is it infinite? And how many bytes does it allocate? I mean, how many bytes does Python allocate to an integer object? Songsu, do you know? Maybe he needs some time to answer. This is just an approximation. I mentioned that this is not accurate. However, we are saving approximately 1/3 of memory space due to storing these dates. But other than that, we need to store like other entities. So it's not accurately 1/3, but it's approximately 1/3. Okay, let's see how we should modify our implementation when we use this Julian representation. What about year? We just need to self. We need to convert our Julian representation into year, month, day representation again. Okay? Like this. So we are calling this Julian day to year, month, day representation. And this one returns year, month, and day. And we need to return year. And in the case of month, we are returning the second parameter, which is month. And in the case of day, we return the third one, which is day. Okay? And day of week, we don't have to call this one any longer because we are storing the Julian day itself. So rather than calling this one, we're going to just return self.Julian day %7. And we're going to use the same function as Julian day and advance by. We need to change this one as well. However, let's skip this part. What about num days? Here, we don't have to call this to Julian day. We just return this one. We don't have to call this method because our object already contains the Julian day. And what about advance by? In the case of advance by, we need to calculate the Julian day without calling this method, but just the Julian day stored and add the number of days we want and convert this day into year, month, day and return this date object. Okay, that was the modification of our date object. However, this is not the all. And as you can see here, as we removed the extra storage space for this date object, the computation slightly increased. So there is usually a trade-off between storage and computation. When we make efficient data structure in respect of storage, then the computation tends to increase. However, if we make our computation efficient, then the storage might increase. So it's not always the case. However, in general, there is a trade-off between the storage and computation. Okay, that was 2 implementations for 180T. And another thing we want to support is when we print D1, then it gives us the address that this object is stored. And how do we solve this problem? We want nice representation, like when we print it gives us nice representation of this string. And when we print out this integer, then this integer gets printed in a nice format. And how should we implement this part? I don't remember if I mentioned this part or not, but we can implement this stir method. Then after we implement this stir method, this one goes into this print method and returns this part. And now it becomes this nice format. And as you can see here, when you implement this stir specialized method, then it lets us how to print. It lets this print function know how to print this method, this object. That is the role of this stir method. Another thing we want to support is comparing two methods. That is specified by this one. This one. We want to compare whether two dates are the same or one is bigger. What I mean by this is, when we compare D1 and D2, what would happen? It will just occur an error. This comparison operation is not supported between instances of date and date. And how can you support this functionality? To support this functionality, we need to implement two other special methods. The first one is this eq method. And here we are receiving right-hand side. And this is another date object. And after we implement this stir method, Python automatically binds the output of this stir method to this print function. And when we implement this eq method, then Python will automatically assign this result as the result of comparing these objects. And you don't have to implement the left-hand side. You just need to implement the right-hand side. Okay? And to compare whether two objects are the same, have the same value. You need to compare the year and month and day. Okay. And after that, when we run this, it will say, oh, these two dates are not the same. However, if you change this one to 19, then it will say, oh, the two dates have the same value. So after you implement this eq method, this equal sign operation is supported. And when you want to compare two objects, then you need to implement LT less than, like this. And you can also implement less than or equal, LE, like this. Then after you implement these two methods, then comparison operation will be supported. Okay, that was how we implement special objects or special type of data for our own applications. Up to this point, do you have any questions? Okay, no questions. Let's move on. There is one problem with our implementation. What if user inputs a wrong number, like 2023 March like 50th? Then even though we pass a wrong number, there is no error occurred. How can you solve this problem? As you can see here, we need to handle exceptions very effectively. And when you actually develop a program for other users, you might spend like third of your time implementing the functionality, and the other 2/3 of your time handling exceptions. Because users would not use your program as intended. Therefore, you need to spend quite a lot of time to handle exceptions. Let's first solve this problem. How can you solve this problem? It's quite simple, first of all. You can solve this problem by converting the date into a Julian date. And then convert back this Julian day into year, month, and day. And if these three numbers do not match, then that is not the correct year or month representation. Like this. So you can handle that type of error in this way. Okay, that is one way. However, there are numerous exceptions or errors occur. I guess you've already seen a lot of errors. When we try to divide an integer with 0, then zero division error occurs. And another error we can make cause is converting a string into integer. Then it says, oh, value error. You cannot convert this literal into base 10 integer. And when you also try to allocate too large memory space like this, then it will say, oh, we don't have that much space. Memory error occurs. There are various types of errors. And this is because users might not use your program as intended, as I mentioned. You need to care about all these types of errors. And even doing so, there might be some corner cases. Anyway, then how do you handle these errors for your own programs? To do so, we use a special block in Python that is called try and except. Let's say we are receiving an integer and convert this integer because this input function receives anything in the form of string, and we convert that string into integer. This is a very simple program. However, as I showed you here, users might not input integers, but some strings for converting strings into integer. And in this case, our program just stopped. However, if we don't want our program to stop when it encounters errors, then we need to use these try and except blocks. I'll show you the functionality of this try and except after implementing this part. And this one catches value error. Yeah, let's run this. This one asks us to enter an integer. Let's enter 10. Then we'll just print out 10. However, when we enter random string, then it will say, oh, HKJ is not a number, like this. So rather than crashing this program, it just smoothly moves over this error. And if nothing wrong occurs inside this try block, then this exception does not have any part. However, if error occurs in the middle, then this exception block will be executed. That is one way of handling errors. And when an error occurs, the program stops right there. I mean, if there are other functionalities like blah, 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 and if an error occurs here, then this program will not proceed to the next part, but it stops right here and goes right into this except block. And then the programs in this except block will be executed. Okay, so you need to be careful about try and except. And you can also define your own exception or error. Here they have value error or memory error and zero division error. And for your own program, you can also define your own error. I'll show you how you can do that. And to define your own error, you need to inherit from exception. This is a very simple exception error. And you can raise your own error. By using this raise, you can occur any error you want. And here we are occurring my error random. And this except need to handle my error random. You can change it as E. And you can print out the error message. Okay, and let's call this main function. Then it says, oh, I'll raise an error, and whatever I enter, it will just an error. It will raise an error. So here, the takeaway message is you can raise your own error, or you can raise a value error, any error you want using this raise keyword. And you can handle your error message by converting this one as E. Then you can do error handling code here. You can write your error handling code here. All right, let's summarize today's lecture. Today, we talked about abstract data types. And we compared abstract data types and data structures. This one was a concept. This one was the actual implementation. And we discussed a real world example. We saw how we can implement the same date abstract data type in two ways. And none of them was better than the other because there was just a trade-off between the two. And we also saw some special methods like this stir, eq, lt, or le to support other functionalities. And we also saw how we can handle exceptions or errors using try and except block. Okay, that's all for today. If you have any questions, you can stay here. Otherwise, you can leave now. Thank you for your participation.